Okay. Hopefully today goes a bit smoother. Alrighty, what are we up to? We are looking at the examiner report for paper 3, right? And Mr. T-Form is here again. Hello, hello.
Hi there. Howdy all.
And also we have a nice question from his Instagram on the screen. I really like these types of questions. What number is the car parked at? Yes, we'll be going through those questions. We'll quickly go through the examiner's report. Thanks for asking, HA. Hello, hello, by the way. Yeah, we're just going to quickly look at identify the issues that led to the questions we wrote. And also, if you have an answer to this question on the screen, shout that out as well. Okay. Also, if the stream buffers at all or like lags a little bit, please let me know because I've been seeing some technical issues and yeah, I kind of really want to identify what's going wrong there. So we already have an answer to the problem. And yes, I think I would agree. It's 87, right? Okay. Alright. Well, let's just jump in. If there are issues, then there are issues. Not much we can do about it. Okay, so paper 3. What do they say in the intro? The time allowed seemed to be sufficient for most students to complete this paper. The great majority of students seemed well suited to entry at the high tier. That's great. Work was presented in a clear and logical way. The paper gave opportunity for students of all abilities to demonstrate positive achievement. That's awesome. Okay, so the questions we identified we'll go through. So question 2, it said there were a disappointing proportion of fully correct answers to part A of this question. It has to be said that there was a great deal of sloppiness in students' notation when making the substitution, and far too many students failed to write the -3 in brackets. They very often wrote 4 times -3 squared take 11, with most students then going on to use their calculators with little understanding of how to deal with the square of -3. Okay, this was a substitution question. Okay, so let's bring up the first problem. Joel, you still with me, by the way?
Yeah, still with you.
Okay. Thought I was speaking to the void for a moment. So this first problem we designed around that question 2, because it was identified that substitution there was a problem there, right?
Well, the main thing I reckon was the fact it was a negative number and substitution. I can say that when you're entering A level, you want to do really well at your GCSE, this particular skill is something that holds you back at A level. So it seems to be something people don't do very well at GCSE, and then they forget about it and think, it's going to be fine. But it does hit you again at A level. It just goes to show people don't really enjoy it or practice it very well. Substitution of negative numbers.
Yeah, so the issue here was we were getting this -2 to substitute into the formula, and people were writing t equals 3 plus 7 times -2 squared, something like this. And for the viewers, T-Formula can't see my screen, so it's a bit awkward at the moment. But you can hear what I'm kind of describing, right? Kind of makes sense what I'm doing.
I'm going to just say I can see your screen crystal clear now. I forced it at 1080p, so
Okay, awesome. Yeah, so we're putting this -2 without the brackets. The correct way to make that substitution would be -2 with the brackets, and then you end up with 3 plus 7 times 4, and that gives you the correct solution. In this case, it would be 31, and then also the rearranging was part of that question, right? Part B of this question was done quite well. Students usually change the subject by subtracting 4 from both sides and then dividing by 3. So the rearranging wasn't an issue. Is that the case?
not so much. No, I
Okay,
feel
so
like it was just there for completeness, really.
yeah. So part B was done well. That's really good to hear. But just to run through it, we would subtract 10 and then divide by 7. So, oh, sorry, we're making k the subject. Yeah, subtract 10, divide by 7, so we get k equals p take 10 divided by 7. Okay, so the key there is when you're making those substitutions, especially with negatives, always include the brackets. Because as they said, a disappointing proportion were making this mistake. Okay, question 4 was the next one. This was a good discriminator between lower attaining students. So what exactly does that mean, a good discriminator? Meaning...
Are you asking?
meaning, I guess that there was like a gap between those that did well on it and those that did not so well?
Yeah, I think it means that it really is a challenge and will sort out those that know what they're talking about. They really have to know the topic very well to get the full marks. I think that's what it is.
Yes.
So what did we do? We changed the question a bit.
So just running through the explanation, they said, despite there being a number of possible routes that students could take, there were also many incorrect and incomplete solutions.
People can get lost in the question. If you think about the question we made, this is the second one, isn't it? Did you put it in the? We have it in the
It's
order. Let's have a
the
look.
yeah,
No,
sorry, it's
it's
the
not.
5th one.
So the fifth one, yeah. So it's quite a lot. It's a big question. There's lots to be done about it. And you can really get lost. All that information and having to keep track when you're halfway through the calculation. So I understand that. I think it comes down to last week we talked about if you find a result, be sure of what you found and maybe make a note of it.
Yeah, so just to go through this a bit more, they said a common error seen was for students who did not appear to have access to a calculator to use a build-up method to find 12%. Oh, and then the error was made with the arithmetic. Okay, that's sad to hear that the issue there was not access to a calculator. Okay, so let's run through this one quickly. Joffrey is going to buy 21 packages of 4 tiles. Here is some information about the cost of packages of 4 tiles for each of the 2 shops. 3 packages for £70, or 7 packages, normal price £190 and 15% off the normal price. He wants to buy 21 packages as cheaply as possible. Which store should he buy from? So if we're working out the cost for hardy floors, well, we need 7 packages at £70. That's going to be £490 for hardy floors. And then to work out home improvement store, we're going to do 100 and is it the same if you multiply then take 15%, or take 15% then multiply?
Are you asking which one are we talking?
Question 5. Well, I'm just going to take 15% off and then multiply. So we take 15% off, in other words, 85% of 190. 85% of 190, and then multiply that by 3. So let's get our calculators out.
I think what you're referring to there is it's a percentage multiplier, isn't it?
Yeah,
Where you
that's right.
figure out what the percentage you want overall and give it that multiplication as a decimal. Very powerful
Yeah, so if
way
it
of
says,
working.
yeah, exactly. So 15% off, in other words, is 85% of that price. So as you were saying, if you want to find the percentage multiplier, you would say that's 0.85 to find 85%. Yeah, thanks for pointing that out. And then we're getting £484 and 50 pence for home improvement store. So if you want to buy the 21 packages as cheaply as possible, you want to go with home improvement store. Yeah, so I guess the main issue with that question was the arithmetic part of it, like making some small mistakes with the percentages, which I could see happening pretty easily.
Lots of words as well.
Yeah,
Because
very
when there's
wordy.
words, it's you've got to interpret what it means, which
Exactly.
math to
Yep.
use.
Next one was question 7. This said, this question was a good discriminator again. Still not 100% sure what that means. What is a question that is a good discriminator?
I really think it means you have to know what you're doing. There will be a lot of parts to it. And then, to get all of them, you have to know everything about that topic, which means that you are discriminating, which discrimination is to tell apart, to make a split between two things, to tell the difference, right? So it must find those that really know what they're talking about versus those that really don't know, and it really tests your metal, right?
Mm. KBS. Just looking at my live stream software. There's this number that says KBS. And it goes up and down.
Kilobytes a second.
Yeah. But there's also a green light, and I think if that stays green it's fine, but if it goes red then it's a problem. So it should be fine.
Perfect. Look, someone's just put up a perfect definition, exactly as we said it
Discriminator,
earlier.
a
So
characteristic which enables people or things to be distinguished from one another. Yeah, I'm using OBS.
yeah, it really allows you to find out if people know what they're talking about or not, meaning it was tough. So we find out who really practiced it.
So but in terms of an exam question,
Well, when you make an exam question, a really good exam question, you need to make it so that you have it's a good one because you'll have a full distribution of results. So you'll get an even amount that don't get it, an even amount that get 1, 2, 3, and 4 marks. That means that you've got a question really well balanced. If you've got a question that they either get all of the answers or nothing, that means that the question is too dependent on one bit of knowledge and people are failing completely on that one bit and it's not testing the full range of the
I see what you
skills in
mean.
that topic.
Right, okay. So it's got a number of different ways to get to the solution, and you can get some people can get some of those steps and others can get all of them, and you can see where students are stumbling, kind of thing.
Yeah.
Makes sense. Okay, so this was question 2, with the trapezium, area of the trapezium. Well, should we run through it, or what do you think?
Oh yeah, for sure. That's a good one. I mean, it has a show that, but I think the real key is how you get the length BC. I think that really is because you know for a trapezium how you get what each side. It's the two parallel sides that are A and B. So we've got one of them that's 2, and the other one is the difficult one.
So how are we finding BC? Yeah,
We,
that's the
yeah.
kind of the question that you need to ask, and I guess maybe a stumbling point for some.
Oh, for sure. Because they're like, oh, well, that's not easy. There'll be some people that can find the area of a trapezium because there are so many posters that make it sound easy. But do you really understand it or do you recognize it as something different? And with the trapezium, you need to identify the height, the perpendicular height of that trapezium, which here is 5x. And then you need to know A and B. A is very easy. Doesn't matter which way around. We'll just call it 2. But the
Okay.
BC is a bit of logic you've got to understand about parallelograms here.
So the formula, of course, is A plus B times H over 2. So the A and the B you're referring to is the top and the bottom of the trapezium. And we're looking for this gray shaded area. So you can think of, well, let's just say that the bottom is 2. So it doesn't matter which one A and B is.
No.
But we've got 2 as one, let's say A. A is 2, and then we need the bottom, so BC. And as you said, we need to use some knowledge of parallelograms to find that, which is that opposite sides of a parallelogram are equal.
Yes. So we've got the full expression down the bottom, haven't we? That's 4x plus 2, which is going to be equal to that whole top bit, 2x plus the unknown. In other words, it'll be the sum of 4x plus 2, take away the 2x, and that'll give us the BC.
Yeah, so to find BC,
Oh, I like that. That's a
yeah,
good tool.
we're doing 4x plus 2, the bottom edge, take 2x, which gives us 2x plus 2.
Yeah.
Okay, then I guess the challenging part is a bit of algebra. It's kind of tricky, maybe.
Maybe. There's some fractions. Actually, it's very different depending on how you've written your formula, because I don't write my formula like you have. So
Oh,
I'd
okay.
be interested to find if it's any easier your way, because I did it a different way.
How do you write
I
the
normally write a half times h
half?
times open bracket a plus b close bracket.
Oh, yeah,
So
that's yeah. Yeah, in some ways that's neater. So you can also write it like a half h a plus b.
oh, I would like you to do it your way though. I'd be very interested to see if it's
Alrighty.
nicer. The way I did it requires a bit of expanding with fractions. It's not terrible.
Okay. So we'll stick with this one.
Yeah, love to see how it works out where it has an
Um,
H.
and then, well, we've got the top or the bottom, doesn't matter. Let's call this the top, 2x plus 2. So and now I haven't arranged the space on this paper very well, but we've got 2x plus 2, which is the top, plus the bottom, which is 2, multiplied by the height, you've already said is 5x of the trapezium, and all of this is divided by 2. Okay, and then simplifying this expression in here, we get 2x plus 4 times 5x divided by 2, and then divide by 2, so we'd get x plus 2 times 5x, which is 5x squared plus 10x. Very nice. Yeah, so I guess the place that the stumbling block I'd identify there is identifying the lengths you needed in the trapezium, and then also being able to manage the algebra to find that area algebraically. Alrighty. HA should be fine. That's the bitrate for the stream video and audio. And 1200 is high. Thank you, HA. That's very useful. Okay, next one was question 10. This question was not done well. Too many students showed the misunderstanding that to reverse a 10% decrease had to increase the value of your car by 10%, so they multiplied by 1.1. Oh, this is a pet peeve of mine. I don't know about you, but the reversing percentages, I really have something to say about this.
I'd love to hear it.
So question 6 is based on this question. It says, Galadriel bought a new boat 3 years ago. Can you tell I was watching Rings of Power, by the way?
I could tell. I love that show. We haven't talked
Oh,
about
really?
it yet, but I
Oh,
love
snap.
it. Yeah.
Damn. Oh, yeah. Yeah. It was like, you read all this stuff and then you actually watch the show and you like it. And it's like, well, what are these people talking about, you know?
I don't know what they were talking. I never listen to reviews. I just do
Yeah.
my own thing.
Did you know who the stranger was?
Oh no, I didn't. Of course not. It was
Yeah.
really sad, but hey, kind of cool in the end.
Why is it sad?
I don't know, because I thought there was something. I don't want to give away any spoilers or
Oh,
anything.
true.
I
Oh,
know,
yeah. So I should say spoilers. Yeah.
I know it's all out and everything, but I just said in the chat earlier, can you tell what kind of TV shows that you watch just from these
Oh, right. Yeah.
questions? We've got Galadriel, which is not a normal sort of name, and then we've got Joffrey. So I know someone watches TV.
Well, yeah. Joffrey. I mean, Game of Thrones. I went a bit off that show, but I think the first 5 seasons were fine. All right. Yeah. So, anyways, we don't want to give away spoilers. Although I think the final episode was pretty good. I think, in my
I
opinion.
liked them all. I liked them all because I loved the show.
Mm.
My dad used to read me those books growing up, and
Mm.
I'm just sad it's over. I'd like to see the next season already,
Same.
but
Only what was it? 9 episodes or 10 episodes? Went so
not much.
fast.
Not much.
Anyways, I am rambling. You're not rambling. I'm rambling. At the end of the first year, the value of the boat had decreased by 13.5%. The value of the boat then decreased by 11% each year for the next 2 years. At the end of the 3 years, the value of the boat was 35,250. Work out the value of the boat when Galadriel bought it 3 years ago. Give your answer correct to the nearest pound. So when it tells you that something decreases by 13.5%, the thing that I see a lot of people doing is to say, well, we can just reverse this, right? If it decreased by 11%, then I can say, well, if it's at the end it's 35,250, I just multiply that by, 111% or something. And this is the issue that I have. Like, if you start with £100 and decrease that by 20%, decrease by 20%, you've got £80. And then if you take that £80 and you increase it by 20%, you don't end up at £100 again,
Yeah, classic.
right? You end up at 20% of 80 is I'm going blank.
96.
96. You'd end up at £96. Yeah, because you're multiplying by 1.2.
And if I'm right, we've got 16 fives in 80. Not using a calculator.
Yes, sorry, you're looking for a fifth of 80. 20% of 80 is 80 divided by 5, which is 16. So you're adding on £16. Yeah, my mind went blank for a moment. So when you decrease something by a percentage, you cannot just reverse it in that way. You can't just say, oh, I'm just going to increase the 80 by 20% and end up with the same amount. So what you need to do is I would suggest creating an equation out of this question. So call the amount we start with x. And there are different ways to do this, but this is the way I would recommend. The starting amount, let's call that x. And if we decrease by 13.5%, again think of that percentage multiplier. Well, if we take 13.5% away, we will have how much left? We'd have 0.865% left. So we can multiply by 0.865. Sorry, 86.5% left. And then if we're decreasing again by 11% twice more, then we're multiplying by 0.89 twice. So we can square that, 0.89 squared. Hey Harminder, glad you joined us. And so this is the equation that I would recommend you try to get used to writing. When you've got these percentage increases and decreases, firstly figure out the percentage multipliers, and then all of this is equal to the end amount, the amount the value of the boat after 3 years. So this is equal to 35,250. Hello Joel, welcome. Alright, so hopefully you understand how I got to this equation. Just running through it really quickly again. X was the starting value of the boat. This is the unknown we're looking for. Then it decreased by 13.5%. In other words, we have 86.5% left of that value. And then it decreased by 11% in the following 2 years. So in other words, we have 89% of that value twice, so 0.89 squared. And then to solve this equation, we divide by these amounts here. So the starting amount is going to be 35,250 divided by 0.865 times 0.89 squared. And because this is a calculator question, we can stick that straight into a calculator.
That's what I love about percentage multipliers like that. You've done 3 percentage changes in just one number.
Yeah, and I think that's a really good reason why it's a good thing to get used to, working with percentages in this way. Maybe not, like you need a different strategy for the non-calculator papers. Of course you can't do this generally in a non-calculator paper, but for the calculator papers this is, I think, the way to go. And then plugging this into a calculator, we get a value of 51,447.3 pounds. So I'm already forgetting what that is. 51,447.3. So that's your answer to that one. George, welcome. 0.89 squared is such a hard calculation to produce. Oh, you mean... actually, I'm not sure exactly what you mean. I would say you can also write just 0.89 times 0.89, because if you notice it's decreased by 11% for 2 years, you're multiplying by 0.89 twice. So you don't have to write the squared. You can just write times 0.89 times 0.89. If that makes more sense, or maybe I'm misunderstanding the issue you're having. Alright, so yeah, the main point I wanted to make there was decreasing by percentage is not reversible in the way that a lot of people seem to think it is. Have you seen that issue pop up much, Mr. T formula?
The issue where, in which sense?
Of that, the percentage, like reversing the percentage, like if you decrease something by 20%, just
time. Like
yeah.
It is the major misconception, right? So you have to demonstrate. You did it with 20%, which is great. I normally do it with 10%, but it's always a shock in the classroom the first time you see it. It's a big assumption, right? And all of those assumptions, those things that are built into our intuition, we do a bit of math to practice to learn how it really is, and that's really important to trust the math and realign our intuitions. Because goodness knows where they can come from. I mean, they come from basic addition, I suppose, but we're applying something slightly different here, and it's good to explore that.
Oh, Georgia was talking about 0.89 squared mentally. Yeah, I wouldn't
I
know.
thought you might. I didn't want to interrupt, but I thought it might be something because I was going to write, you mean doing that calculation by hand? And yeah, there's a lot of methods for that though.
Okay, sure. I mean, well, this would never be on a non-calculator paper, but I guess so. 0.89. I can't see a shortcut. I guess you could do zero point 0.9. What would it be? So 89 times 89. Yeah, I'm not
That's probably the
super.
simplest way, isn't it? Like multiply the 0.89 by 100. If you do the 89 times 89 using any standard methods like written or box method, and then oh yeah, you could do difference. You could do something like that. Um, However you would do it, and then make sure you divide again by 10,000 at the end.
Oh, so you're saying 100 squared divided by 10? No, you lost me. Sorry, I'm not
Well, no,
quick enough.
however you do 89 times 89, you're going to have to undo that because we have something like we have it 10,000 times bigger than the question will be right now, right?
Yeah, yeah, yeah.
So
Yes, yes.
90 squared, you got your 8100.
Yeah, I was just thinking this would be the shortcut I would take, like thinking about it as two-digit numbers, then
Yeah, no,
dividing
that's clever
by
enough, yeah.
1,000. Would it be 1,000? No, 10,000. You're right. Yeah. Yeah.
Yeah,
So
200s.
that's still not, yeah, still not fast. That's not the fastest way. I think that'd be a better shortcut. So what's that? 8,280. No, sorry. 7,920. 1. I didn't even do that in my head. I had to use
That's
a paper.
7921, I make it 7,791.
So is that
And
point
then divide
zero?
by 10,000 gets you where we were.
0.7921 or 0.07921?
That would be seven. It would be seven. You've got
Yeah, yeah.
four zeros, isn't it? So 0.7921. There's your one.
So that would be a air quotes mental method that I didn't do mentally, but that's if I was feeling, energized, then I
I think
would,
there's definitely worse numbers to multiply though.
yeah. Horrid number. I agree. Okay, question 14 was the next one. A minority of students scored 4 marks for their responses to this question. Which one was this?
14 is your one. You did this one.
Factorized. Oh, fully factorized. Yeah, yeah, yeah. Fully factorize.
You made a really good question, by the way. I think I just want to say that. I don't know if I told you. I
This
think this
one, the
is a
factorizing one?
good twist. Yeah, number seven. It's a good twist.
Yeah, I mean, the difference of two squares I think trips up a lot of people. This is EdXL, yes, George. The difference of two squares I think is a common place for people to trip up because often you're not expecting it, right?
Yeah, but
Like,
you've done a great question because you can't see square numbers right now. That's what I
yeah,
love
and
about
and
it.
maybe I made it like harder, and maybe it shouldn't be harder given that already students were struggling with it, but so let's just have a look at the issue again. So most students were able to gain some marks, and the question was a good discriminator, there's that word again, good discriminator, between students who could manipulate algebraic expressions with accuracy and those who made sometimes unnecessary errors. It was disappointing to see so few students factorize the expression fully. Okay, so obviously, well, maybe not obviously, but you can see a common factor here of 2, and maybe higher. Um, No, 2 is a common factor, is the highest number that you can factor out of both. So hopefully, I think it would be common for most people to get that first step of factorizing the 2 out. So this would be 2 times 9x squared take 49. Then you need to see the difference of two squares. And maybe this is the place where a lot of people stopped. So they factorized the 2 out. Oh, I don't have any more common factors. There's no x in both terms. There's no other numbers in both terms, so I'm just going to stop there. And you need to remember the difference of two squares. I have a video on this if you want to check that out. Going through in detail. Don't know what happened to my pen there. Went a bit crazy. Write that down. Difference
Yeah.
of two
What
squares.
is that?
Difference of two squares. So meaning you have two squares and they're subtracted. It's the difference of two squares. Here I have a 9x squared. I can write that as 3x all squared, and 49 I can write as 7 squared. And this I can write as 2 times 3x plus 7 and 3x take 7. Again, I have a video on this if you really want to understand why this happens. Check that out. But this is always the case. Anytime you have a square, something squared takes something else squared, you can factorize it in this way. So just be on the lookout anytime you see a factorizing question in an exam. When they say fully factorized, be on the lookout for the difference of two squares. Alright? Really common place to trip up. SA says DOTS, exactly. 3x plus or minus 7. 3x plus or minus 7. Awesome. Well done, guys. Alright. That was a place people tripped up. Question 16. This question discriminated well between more able students sitting this paper with many students being awarded each of the 0, 1, 2, or 3 marks available. Okay, so this was the upper and lower bounds question, right?
Yeah.
Did you want to talk us through this, or
I can, yeah, why not? You can do the writing, but it basically it throws a bit of a wobbly one because you don't expect to see that root there, and if you've never seen it before, you start to think, what does it mean? And then you start to doubt yourself. So question number 3 is 4.7 is correct to 2 significant figures, so it's just exactly as you see it, and B is correct to 3 decimal places, and we're looking to find the lower bound for D, which means we want to find, if we put these into the formula below, we want to find what it would, well, which part of that would we do to like upper bound or lower bound to get the smallest out of the value of D. Because M has got a whole like range, and M could be as high as whatever it was before it was rounded, or as low as something, and that will change the value of D. And you might not think by much, but when you calculate it, the error, it gets multiplied and amplified. So let's have a look at this. So we start with finding the upper and lower bound for M. So I've got a little trick to do this. We have 4.7, and all we do is we add a 0 to the number we're trying to find the upper bound to. So that would be 4.70. And then we take the final 2 digits from 4.70, which is 70, and we simply add 5 to it and take away 5, and that will give us the upper and lower bound. So for the upper bound, we have 4.75. I'll say it like that because I'm focusing on the 70. So 4.75 is the upper bound, and the lower bound is going to be 4.65 because we're going to take away 5 from that 70. And this little method that we did there is one number it doesn't work for, which is the number 100. So I urge you to have a go at that in your own time to see. We'll do the same method for B.
Hey, can we go into that a bit more, or Sorry to interrupt.
Yeah, sure. Go
Yeah,
on.
so I was just interested. So what you've done here is you've written this point for 4.7 as 4.70, and then you add the 5 and subtract the 5 from that
Yeah,
number to get
that's
the
the
upper and lower
symmetry
bounds.
of halves that we can see in most numbers, but doesn't work for 100.
So 100 would be so well it would if you said to the nearest tens, would it?
Yeah, it works under certain conditions,
Okay.
but if we said it was 100 to three significant figures,
Right.
you'd be
Yes.
trouble.
Yeah.
You'd be in trouble for that. Yeah.
Okay. Sorry to interrupt. Okay. We're on to
No,
B.
that's cool. It's just an exception I found recently, so worth noting. So B now is correct to three decimal places. All we're going to do is write it as 0.008, add a zero, and the final two are going to the final two figures there are going to be 80, so 80. Now, if we underline the 80 is what I like to do, just focus on it. And then we add 5 to that and take away 5. So that's going to be 0.0085 for the upper bound and 0.0075 for the lower bound.
Okay. Yeah. Yeah. So we're kind of treating that 80 on the end as we sort of can ignore the other, in a way, like air quotes, ignore the first zeros and just look at that 80 and think 80 plus 5 and 80 take 5. And that's how you're getting upper and lower bounds.
Some people get confused here because clearly 0.0085 will round up to 0.009.
Like me.
But we've got to, yeah, we've got to remember that this, in fact, is the upper bound, but it's not the accurate answer. In fact, the accurate answer is written as Maths Explained has done there with the inequality, which is called an error interval, because the inequality tells us it can never equal 0.0085. It's always that tiny bit less than 0.0085. Do you get extra marks for writing in blue ink? And I'm
Yes.
just going to say right now, in this chat, yes. In the real thing, no. I think you don't get much because they tell you to write it in black ink because they photocopy all of your scripts to send them around the world to get marked now. So you can't even draw in pencil anymore because they need to photocopy it.
Yeah, yeah. Black ink
Right, where are
only.
we back to the question? Now we've got to think about these we've got to think about these two scenarios now. The fact that the d is being square rooted is neither here nor there. We can just square both sides and we end up with a fraction which behaves much like a fraction. It's just there to throw you off. Don't throw a wobbly one. Just think, what effect does that have? We want to find the lower bound of d, so why not let's get it on its own? And what does that square do? Well, all it does is amplify. It just makes bigger the situation that we have here. So if we were to square d, square the answer at the end, and that number was as big as possible, then that would make it bigger. And if that number was smaller, it would just be smaller. So we can safely ignore that for many reasons. We now look at what, in terms of a fraction, would give us the biggest value. The biggest number in a fraction is where we have the maximum as the numerator. So we might write that as m subscript max. So yeah, you can sort of have two sections here, one where we write for finding the largest and the lowest. Or then when we're trying to find the d minimum, we might be minimizing that top value. So it would be min at the top instead of max. So yeah, that's an example of the max, but we don't need to do the max here because we're doing the minimum anyway. So may
Yeah,
as well just focus
just
on
for
that
people
one thing.
watching, in case it sounds awkward, I'm the one writing because we couldn't get the whiteboard set up. So T-Film's doing a great job of explaining, which I'm sure is feels very awkward and you can't actually write on the screen. And again, I apologize for that, but we'll try to get something set up for next week. But yeah, so we're at
Yeah,
M min.
I wondered like what that would feel like to other people because there might be a delay and it might look like I don't know what I'm doing with the pen.
Yeah, yeah.
So the what we were looking for is the minimum value because we want the lower bound for D. That's going to mean that on the fraction on the right, we want this number to be as small as possible so that when we square it, it's still small. So that would mean m would be the smallest number possible, so m min, and the b value that we're going to use, we want it as big as possible because when the denominator is large, then we have a smaller number overall. So this would be the aim. We'll be using the m minimum and the b maximum, which you can see earlier where we did 4.75 to 4.65. So we're going to be using 4.65 for m. And for B, we're going to be using 0.0085. Yeah, flailing around.
Yeah, so
I love being able to write at the same time as talk, for sure.
yeah, yeah. We'll get something working out for next week,
So for the
hopefully.
interests of everybody else and not feeling too dizzy, why don't you take it from here in terms of putting it in, and we'll catch up at the end.
Yeah, yeah. So as you said, to minimize D, to find the lower bound for D, that's essentially what that means. We want the highest numerator and lowest denominator. So M min 4.65, B max 0.0085. So then we're going to get D equal to 4.65 divided by 3 times 0.0085 all squared. If you plug that into a calculator, 4.65. Oops, I forgot my brackets. 4.65 divided by, do I need brackets there? Maybe 3 times 0.0085 all squared, and we get 33,252.595. Now we didn't give a what to round off to here, but let's say to two significant figures.
Yeah, absolutely.
Three.
It's a very standard. In fact, let's talk about that. If you don't know what to do, in mathematics pure exam, a question with maths should be two decimal places. And if you're a statistics question, then we should be working to three significant figures. If you go to those as a default, you can't really go too wrong.
Oh, what did I say? Three significant figures. I meant two decimal places, sorry. But yeah, we could
Yeah,
also
let's
do.
let's use 2DP for maths questions, I think.
Yep, yep. Okay, so approximately 33,252.6 for that one. So what was the issue there, mainly?
To be honest, it's in my opinion, it's the fraction. And everyone I've ever taught this to, um, they don't understand that if there's a fraction, you need to not use the biggest numbers to get the biggest number. You need to use the biggest number on top and the smallest number on the bottom. So it's having an appreciation of how a fraction gets larger or smaller based on whether the numerator or the denominator is big or small.
Hmm.
Yes, George, that's a very huge lower bound. But everything has a lower bound. The most important thing is how relative it is compared to the upper bound. And that could be a calculation you do for yourself to see what kind of range. I was recently looking at Tesco's profits back in a few years ago, where they exaggerated their bounds. Okay, so they were rounding very large sums of money and they were really keen to make it look good because that means they get a bonus at the end of the year. And it was something like 250 million pounds was the difference between their rounding errors. So obviously they got told off, lost their job, and Tesco's was in trouble. But rounding can cause a lot of problems. I mean, it's a bit soothing if you're trying to make things look good, but it'll catch up to you.
Is that related to standard deviation at all? Trying to think how this
I'm
would
trying my
be.
best to relate it to standard deviation. But I would say it's related in a sense that there is some sense of variation in life always. So when you're looking at this number that was rounded because we can't deal with that sort of accuracy. And so there's always the idea that we could have measured it more. So everything you ever measure, you had to stop at some point. Most people stop at millimeters. So yes, in a sense, there is some sort of normal distribution around what we can measure and the error involved.
Hmm.
And in that sense, it is some sort of measure of spread of our abilities as humans to measure the world around us without technologies or sometimes with technology. And the same, standard deviation is some sort of measure of spread away from the average.
No, no more £3 meal deals. Yeah, that's criminal, right? Used to be what I'd get for dinner every night or lunch. Yeah, so standard deviation I would generally relate to an average. And yeah, as you say, I guess you could find some kind of average. Yeah, I'm not really seeing the direct connection,
I,
but
I don't think it's direct. I think it's more that I'm trying my best to see a connection. And I think it's something to do with that there's a spread around a particular number. And over maybe at least 1,000 measurements of a particular thing, you could set the error as some sort of standard deviation because you'd have an average error that people were making. But that's such a stretch.
yeah, so just looking at these comments again, they said some students did not attempt the question. Maybe it looks scary, or they weren't confident with upper and lower bounds, and many restricted their answers to working out the value of p by just substituting in the. I'm getting some feedback from your mic, by the way.
Okay, hold on. Let me turn my thing down. Go on.
Yeah, by just substituting in the decimals as they were and not finding the upper and lower bounds. So really, I would say probably the issue with that question mainly is the upper and lower bounds part. So practicing that topic, I think, would be really key. Making sure you're confident with upper and lower bounds. Okay, on to the next one. Question 19. Oh, this was algebraic fractions. Fully correct answers to this question were seen infrequently. However, a significant proportion of students taking this paper were able to score at least 1 mark for using the correct common denominator and writing at least one of the 3 terms with that common denominator. So, full marks for this algebraic fractions question were rare. You mentioned statistics. Think bounds tie into sigma or something. Root of d does not equal root of variance or sigma. Root of d is not equal to the root of variance.
I think are we saying that it looks like it's tied into standard deviation because the square root of variance equals standard deviation, so it looks like it in
Right.
that way.
Okay. So the
Maybe it's something
formula
like that.
kind of looks
And
similar.
George is right. It's not like anything like that.
Okay, yeah. Yeah, not quite. All right. Whoops. Okay. So, algebraic fractions. I think, as I say, the first step here, I think, was maybe done well.
This is your question, right?
Yeah,
Take it
yeah.
away.
Yeah, so we need to, just like combining fractions, we need to combine these fractions. We've got 3x over x plus 3, take x, take 2 over x, take 3. To find a common denominator, we want to cross multiply. So we're going to do 3x times x take 3, the multiplied by the denominator of the other fraction, and then we're going to do x take 2 times x plus 3. Right? So you do this all the time when you're adding fractions, right? Let's say we had a third plus a fifth. what would you do here? You'd multiply the 5 by this fraction, and then multiply the 3 by this fraction. So you'd do 5 over 15 plus 3 over 15. Or at least I hope that's what you do. So we're doing that same process here to find the common denominator, which is x plus 3 times x take 3. And then looking at this, that's one of the hardest steps, to simplify the fractions in this way. Because now all you need to do is to simplify. So simplify the numerator. Don't be scared by all of these terms and brackets. Just proceed as you normally would. Multiply out these brackets, multiply out these brackets. And we're going to get 3x squared take 9x. Subtract x squared. Now I'll put a bracket around all of this. So you're going to get a quadratic here and put brackets around that whole quadratic, because that negative is going to be distributed to all the terms. So x squared plus 3x take 2x take 6. And now for these double brackets, maybe you recall from our previous, from one of the previous questions, the difference of two squares. Here I have x plus 3 and x take 3. I can write that as x squared take 9, or you can just expand them as you would normally expand double brackets, and you'll find it's x squared take 9. Okay, and then we also have the take 2 on the end. Keep simplifying. Distribute that negative, so we've got 3x squared take x squared, that's 2x squared. And then negative 9x. This is 3x take 2x, which is x, so negative 9x take x is negative 10x. And then negative 6, which is plus 6, all over x squared take 9. Hopefully I haven't made any errors there. Looks good. And now with this negative 2, you also need to combine it with this fraction. So you need to do, again, you need to find the common denominator. So what you need to do is multiply the 2 by x squared take 9. So it's going to be take 2 times x squared take 9, all over x squared take 9. Okay, then again keep simplifying. So we've got 2x squared take 10x plus 6, subtract, let's write it like this, take 2x squared take 18. Okay, so I've multiplied the 2 by the two terms in those brackets there. And also have that negative outside of the brackets, showing that that negative needs to be distributed to both terms. And we have the common denominator of x squared take 9. Okay, so a lot of steps here. I can see why this, well, a lot of steps to trip up on, so I can see why this question can be difficult for a lot of people. But it's all pretty logical, as long as you're confident with fractions. So let's keep simplifying. 2x squared take 2x is 0. Negative 10x, there's no other like terms with negative 10x, so we're going to have negative 10x. Then we've got plus 6 plus 18, so that's plus 24, all over x squared take 9. And we needed it in the form of ax plus b, and we have that. So we've got a equals negative 10 and b equals 24. All right. I assume the negative 2 is where people would get confused at. Yeah, that's a really good point. So what to do with this negative 2? You know, combining these fractions seems maybe clearer. And then, well, what do I do with the negative 2? Well, because we need it as a fraction, you need to be thinking, well, I need to combine it all into one fraction. Even if it's just a number, we still need that common denominator. So yeah, anytime you get a question like this where it asks for a fraction in this form, where it's all in one fraction, and you have, whatever you have there, you need to find a common denominator for all of the terms so that you can combine them all into one fraction. Alrighty. Haven't covered algebraic fractions in a long time. Good refresher. That's good to hear. Awesome to hear. Always read 2 as the inverse or upside down 5. Well, in Australia we write all of our numbers upside down, so yeah, I can relate. That was a joke, by the way. Okay, question 21. Have you won your competition, by the way, Joel?
No,
Oh, okay.
not a winner tonight, but hey, it's always tomorrow night.
Yep. Question 21 said, higher attaining students usually made a good start on this question on probability. I identified the non-replacement nature of this problem. Oh, this was the probability question. I really like this question, by the way. This was the thumbnail question, so I guess it's appropriate. It's the last question we're going through.
This one. Do you want to take it because of the whole delay thing?
Yeah, there's a lot to talk about there too, though. So I think it's something we can discuss.
Fairs. Okay.
So higher attaining students made a good start. What does that mean? Does that mean a lot of people didn't attempt it? Maybe.
I think so. I think it means those that that got pretty much above 70% overall were the ones that did well on it. Something like that. Specialist knowledge reserved for those that really mastered the area.
They said students
Well,
who
I mean,
drew...
nobody likes statistics, do they? Let's face it. I mean, not many people do, and it's grown on me.
Yeah. Yeah, I was in that camp, maybe. I'm not sure.
You know what I think? I think that this question has some skills that you need for mathematical proof as well. And in that regard,
Yep.
people hate proof as well. So,
Yes, I agree
what
with
can
the
you
odd
do?
and even numbers. So I just wanted to point out, they said students who drew a tree diagram were generally more successful at finding all 4 correct combinations.
You know me, I don't draw tree diagrams anymore. Too old for that.
All
I
right.
do it in my head a bit, right? I tend to use combinatorics, where I write down all the possibilities. I simplify the possibilities and write them down. And then I cherry pick what I'm interested in and pretend that I have a tree diagram and multiply the probabilities across. You could even, if you wanted to, do binomial theorem here, because you've got the n choose r.
Yeah. So
I think we need to start this
choose
question by
9 choose 3.
explaining to everyone that there are certain numbers here that are odd and certain numbers
Yep.
that are even, right?
Let's read the question. Let's present the question. So
Present it first.
Maths
Okay.
Explained takes 3 cards at random. He adds the score together. What is the probability that the sum is an odd number? So there are 9 cards: 7, 8, 9, 10, 11, 12, 13, 16, 17. And as you were saying, we need to well, there's 2 parts to this question. There's the probability, obviously, and then there's the understanding odd and even numbers, as you were saying.
That's right. So that's really what it boils down to, because we want to know the outcome of odd and even. So we don't want to be fussed about the numbers themselves as values. We just want to think of them as which ones are odd, which ones are even. And personally, I used colors, but you can't in the exam. So you probably want to use O and E next to those
Right, yeah.
to denote.
That's a good idea. So which ones are odd? Let's write an O for the odd numbers. Okay, so we've got 5 odd numbers, and then even, we've got 4 even numbers.
Okay, I
Whoa.
found this on the web for what 5 odd numbers and then...
Jeez, Siri, calm down. Sorry about that.
Oh man.
How do I turn off Siri? Okay. So five odd numbers and 4 even numbers.
Yeah. So that's the case. That's where we're at. And now we're thinking if we are going to take cards at random and we're going to add those scores together, like what result would they be? So I don't want to think about them as in, okay, 7 and 8 add 9. I just need to know generally that two odd numbers are going to give me an even. So in fact, let's write that down. So there's only really 3 possibilities that we need to have written down to help us as we go along. The first one is odd plus odd equals even.
Right.
Or I think we just use O. But yeah, odd and odd, that's
Sure.
fine. And then the second fact would be what if they're both even? So that obviously equals an even number overall.
And we are picking 3. So should we do 3?
We are picking 3, but I'm just thinking in terms of what I need to know about it.
Sure, yes.
The other scenario was an odd plus an even equals an odd. But yeah, sure, you can do it with 3s. It's just that doing that,
understand.
there's a lot of combinations there.
But
I suppose there's only.
this is
I
like
can
the
go through them all.
fundamental.
I was going to go through them later. It's just 3 facts that I like to write down, so I remind myself about the patterns around odds and evens.
Yeah, these are like the fundamental ideas of adding odd and even numbers. I like it. Yes.
Yeah, they're just the fundamentals. And now we'll think about the combinations, as in we write down all the possibilities. And in fact, with 3, that we pick 3, there's not many, actually. So there's 8 in general. And when we write down all of the possibilities, this is called writing the sample space. So we can start very logically with OOO, which is, let's say we pick up 3 odd numbers. And we can talk about it in terms of odds and evens because that's really the only thing we care about at the end of the day. We don't really mind. Okay, so the next one would be odd, odd, even. So we've explored where they're all 3 are odd. The next row down, we're going to explore where we've got 1 even. So odd, odd, even. And then that even number could be in the middle. So we could do odd, even, odd. And the last scenario, right, odd, even, odd there. That third line needs to be.
Oh, sorry.
Probably, I'd like to get rid of the third line completely, actually, and move it up. Is that possible? Only because you can see the pattern of what I was. Yeah, that will work. Yeah. So you've got. Okay, so we've got odd, even, odd. Good. And then even, odd, odd. And you like the reason why I do it this way, so you can see there's a pattern there, a physical pattern. You can see the E slowly moving left. And I know I've exhausted all the possibilities. A lot of people try and write down all the possibilities and they get lost thinking, have I got them all? But if you keep this structure to what you're doing, then you won't. You'll know you have them all. The next is where we're going to explore 2 evens. So we're going to have even, even, odd. So we're increasing the amount of evens in our 3. So we've got 0, 1, and 2. Then the next will be even, odd, even. And then the last one would be odd, even, even. Now you can remember, you can use the exclamation, well, not so much the exclamation, it's the NCR button on the calculator, George. And that's just below around the AC button generally. And so you can look now, we're looking where there's 2 evens, but if you think about the 2 evens as 1 odd, you can see that the odds are in a diagonal there. Now we've got one last scenario, is where they're all even. So if we just say E plus E plus E at the bottom, we've actually exhausted all of our possibility. Yeah, that's really nice to see that. Yeah, the diagonal. This structure means that you know you've got them all. The last is even, even, even. So we've completed the sample space. So we can, using the rules on the left, we just work through and see what we've got. So in order, we will get odd, even, 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 odd, 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 and even.
Wait, I missed one. Odd, odd.
It'll be odd evens.
Oh, yeah, that would be even.
It
Yeah,
definitely starts with odd.
I should have used my brain instead of just. Yeah, these are all even. Then
Yeah, I mean,
even
you
plus
can work
even.
through it for sure. Like two
Then-
odds are going to make an even, then two evens are going to. So
Yeah.
you can see they're all the same because there's two odds, right? In these next three, there's two evens in all of them. So they're going to create an odd overall. So there's patterns to be seen everywhere. Now, we're looking for the scenarios where it's odd, right? This is what we're looking for. There's only in these situations where it's going to happen. So we can highlight the 4 that are odd, but there's really patterns.
So I just want to zoom out for a second and point out something that wasn't immediately obvious to me. And maybe it's obvious to other people, I don't know. But when it says you take 3 cards at random, the order matters, right? So it's different if I pick, for example, a 7, then an 8, then a 9. That's a different outcome to if I pick a 9, then an 8, then a 7. Like that, they're 2 distinct possibilities, even though you end up with the same sum. Because we're talking about the order that you pick them, would you say that's a correct interpretation?
As far as our outcome, we don't really mind because what we have is just odds and even numbers. It's a fairly good question because I feel like people they probably want to know the answer to that. But basically they're identical. Basically what we have is just odds and even numbers. And since the outcome is just an odd, we only care about whether that number is odd and even. We account for all of those different combinations because we know it doesn't matter what the number is as long as we know whether it's odd or even.
Oh, sorry, my example was bad. I meant, so for example, if you pick a 7, a 9, then a 10, because we're going to be considering, for example, an odd pick plus an odd pick plus an even pick, different to if you pick an odd, then an even, then an odd.
No. With your example, 7 plus 8 plus 9, it doesn't matter if it's 9 plus 8 plus 7.
No. Yeah, as I said, that's a bad example. But for example, if you picked like 7 plus 9 plus 10, are we considering that different to 9 plus 10 plus 7, right? Because we're considering, when we work out this probability, we're going to be considering odd plus even different to odd plus even plus odd, right? They're 2 different samples.
Yeah, kind of. So if you look at the numbers themselves, you'll get confused. If we look at the fact that they're odd, even, you can see that in that section you've made a diagonal, we have 2 odds and an even repeated 3 times. And if that's what you mean by the order, then yes, that's important because although they're all the same, and we're about to talk about that, they are all the same. They're 2 odds and an even. It matters like where the even is. So in that sense, we do have 3 the same. So the first one we look at, for example, is look down the bottom where we've got even, odd. That's going to be very different to picking out even, odd, and even. And so it has to be unique. But in terms of 7, 8, 9, and 9, 8, 7, yes, that could be one of the differences. But it's not exactly set. But what is definitely certain is that what we have here is a focus on the odds and evens, and we've written out all the different possibilities that it could be, regardless of what the numbers are themselves. So we're working through and looking for the odd numbers at the end, right?
Okay, so we're focusing on we're looking for an odd number, so we're focusing on the outcomes that give us an odd number. So odd, 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 even, odd, even, or odd, even. So we need to work out these probabilities.
And if you look, those are literally the only options. And those are the 4 that we're interested in. So we need to consider each of those only from an odd and even standpoint. We're not going to get bogged down by the actual numbers. So looking at the scenario, well, you'll find there's a really nice pattern, but we'll talk about the first one on its own first. Look at the odd, odd, odd. If you were to pick up an odd number in the first case, what's the probability of doing that if there's nothing taken, everything is as it is at the top? You have how many odd numbers? We've got 1, 2, 3, 4, 5 odd numbers currently, right? So if you have odd, 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 the probability of picking up an odd number to begin with is 5 out of the total number of cards there, which is 9. So that's the first probability. Now let's say that first one is an odd. Then the second time we pick it up is going to be A, 1 less card, and B, there's going to be 1 less odd number. So we're going to be multiplying this because this is our second event, because we want an odd and an odd. And whenever we have and, we multiply. We're going to be going down by the total, so that's 8. And we'll be going down by the odd. And the final odd number, again, there's going to be 1 less. So that's going to be out of 7 this time. Yeah, that's one way of thinking about it. And then there's going to be 1 less odd overall. We'll stop and just consider. In the exam, you will get marks for simply writing 987 for showing that the denominator is going down by 1 each time. That is the observation of a conditional probability. So we see that we've got 504 as the denominator. Yes, George, thank you. And then on the top, we've got 5 times 4 times 3. And that's going to come to 60. But what we're going to find is that this scenario is pretty much repeated. What is true about what we just did when applied to the other 3 that we have to do? Well, we can see that the cards will go down by 1 every time we pick one out. So for all those 3 scenarios left at the bottom, it will always be 9 times 8 times 7 on the denominator. So we're always going to have a 507 on the bottom of all of those, which is really cool. Let's think about the number on the top, though. With the number of evens, we have 1, 2, 3, 4 evens. So in every case down the bottom, we have an even and an even twice. So the numerator tells us how that particular category will decrease. It's going to start off at 4 for the even numbers. Therefore, in all of those scenarios, we're going to have on the numerator a 4 times a 3 at the top. And then because we've got an odd as well, then there's always 5 odds to begin with. That's going to be times 5. So the denominators will be 9 times 8 times 7, just like at the top. And the numerators will be 4 times 3 times 5. In other words, they're the same. So every one of those 4 scenarios is going to be 60 over 504.
So as you said, we don't really need to do the calculation because for even, odd, even, and odd, even, we're going to get this same probability. So these are all 60 out of 504.
You look at the patterns, you see that's, I mean, you could do it all one at a time and you'll see, oh, it's the same numbers every time. Yeah, you missed the 4 on the second one there, over 504. So basically you don't need to do all of that working. It comes to 200 well, let's talk about what you do at the end, because those are the 4 scenarios that we're interested in. We say, okay, it could be odd in this case, or this case, or this case, either one of those will do.
So
And if that's the case, we'll add the probabilities together.
someone's asking why is it 3/8 for the second.
So for the second one,
Oh,
an
sorry,
odd.
I wrote. It's meant to be even and odd. That
I
was
think
my
the
mistake.
confusion is because the label on the left
Yes, yeah.
was supposed to be, yeah, even, odd as an example.
Thank you,
So
HJ, for pointing that out.
yeah, that's a good observation. In the end, it didn't matter, but there's so many scenarios where that could have mattered. So good for the observation. So now we have these 4 scenarios which can give us a win, or what we're after. And in that case, if either of them work, then the probability laws say we add them together. So if we have 60 over 504, 4 lots of that will give us 240 over 504. Okay, so here we go. We've got Mr. Thorough. And then all of those added together is 240 over 504. There's something really good about seeing it all written properly. And that will cancel down to 10 over 21. What does that tell us about it? What is 10 divided by 21? I mean, we know 10 divided by 20 is going to be half. So 10 over 21 is just less than half. Chance of getting an odd. It's a pretty balanced game overall. If you wanted to bias it towards an odd, then that's the one.
Very cool. Very nice question. I'm going to be a bit pedantic here and just talk about something that maybe nobody else cares about, right? I'm going to bring up this idea again of the order of picking the cards. So we're saying here it's different if you pick even than odd. That's different to even than odd than even. So essentially we're saying, or are we? We're saying something like 10, choosing 10, then 12, then 9 is different to 12, then 9, then 10. Are we saying those two outcomes are different?
They would be one of the combinations that would be different, yes. But you have to be careful because many options fulfill those 2 examples you've just given. You could switch the 12 for any other even number. But the most important focus is that there are 2 evens and 1 odd. And we cover all of those different possibilities with the numbers when we look at the different combinatorics down the bottom, and we turn them into fractions. And the fractions will represent how many of those are odd at any given time. So, for example, 5 out of the 9.
Yeah, maybe this is why they suggested the tree diagram showed the most success on this question. Because when you're drawing the tree diagram, why can I do this? I'll just do it here.
I agree with you. The tree diagram seems to make it somewhat clearer because I'm going through my method, which is a tree diagram with combinations. Like those combinatorics down there are literally the branches of a tree diagram. But the tree diagram is very powerful. You're going to need more space, I think, for a tree diagram.
So I guess the point is the tree diagram kind of forces you to ignore the numbers. So if you say you've got 3 picks on this tree, you're forced to write even then odd instead of numbers. And for the second branch, you're forced to again make 3 branches even. You make 2 branches, even and odd.
Yeah.
And then when you get to the end, you end up with the 9. wait, eight branches. And with the tree diagram, you're just you kind of move away from the numbers, and then you focus on the parity of the numbers, and I think that makes it maybe clearer in a way.
That is such a great point, and I'm glad you came back to that now, because you discovered the point of why the tree diagram was better, because you are focused on that instead. Yeah.
Well, I'm not saying it's better. I'm just saying, as a like for people learning this topic, maybe for you that you're more advanced and you kind of you've got the tree diagram in your head, but maybe for learners, it's still important to include that step. Obviously, if you see this question and you're confident, you don't need to worry about the tree diagram. I would still fall back on that as a possible option.
Yeah, we're familiar with tree diagrams, aren't we? We've done it for so many years, and it's something to lean on.
Yeah, so final answer 10 out of 21. Very nice, very nice. Okay, and then I had a bit of a bonus question on the end here to do with square roots. I don't even know if this is in the GCSE spec. It could be. I guess that's a bit mean to put it in here. But there's no problem with a bit of a challenge. What is the symbol percentage? Omnipotence was 3% off. Okay. So for this one, when you have square roots, it's hard to suggest a general method when you have square roots. It can often be a little bit tricky, but here in this case, it's simplest, I think, to have the square roots on separate sides of the equation and then square both sides. So if you write it as square root of 3 take x equals 2 take square root of x take 1, if you square both sides here, it's a little bit cleaner. So if you square both sides, you get 3 take x. And over here, you're going to have to expand some brackets. Yeah, this is probably not in the spec. It's a little bit harder, but let's just do it quickly. So 2 take 2 root x take 1 take 2 root x take 1 plus x take 1. And next, oh, sorry. What have I done here? 2. Oh yeah, sorry. 3 take x equal to 4 take 4 root x take 1 plus x take 1. Keep simplifying. 3 equals, the x's would cancel. No, they wouldn't. What am I talking about?
They always look like they do because you've got a plus and a minus, but something special happens when you add it to one side.
Let's write it as like this. Negative 2x equal to 4 take 1 take 3 is 0, so negative 4 root x take 1. And now, to get rid of that final square root, we can square both sides. So we get negative 2x squared equal to, I don't know why I put this question in here. This is a bit too hard for GCSEs.
This is the sound of regret.
Yeah. Yeah, this is like you get to a lesson and you put a question in the lesson that's way too hard for the class, and it's like, oh no, what did I do?
16x minus 16.
And then you get a quadratic. Then you can divide by 4. Sorry, plus 4.
That last one, yeah.
And then you can factorize. Okay. So
Okay, look, Matt explained this has gone down okay with HA because this is a challenge. It's appreciated outside of the curriculum spec.
yeah. All right.
I can say with these challenges, like it is important to do them because you will find your GCSE gets easier if you expose yourself to these sort of challenges.
Yes. But yeah, I mean, equations with square roots they are kind of a different skill, I think. In a way, because you kind of there's tricks as to when to like what to do with the square root. Sometimes it's different. Sometimes you might want to even substitute something in for the expression under the square root, and that's yeah. So anyway, x equals 2, the final answer. Oh yeah, it's the original equation.
Ah, nice. I thought a balance point there.
Okay, so they were the mock revision questions based on the weaknesses that were identified in the exam report. Hope that was useful to everyone. Thanks for tuning in. Thanks for participating in the chat. George and HA and Omnipotence. When is the next stream? T-formula.
Well, we're thinking, every Tuesday could work.
Oh, great to hear. Yeah, so next week, same time, same place. Maybe we'll try once to do one on your channel. If
Could we do a Rings of Power discussion?
Yeah, I'm up for that. A
I
breakdown
love
of
the show. Yeah, it's brought me to tears, I tell you.
Oh, the other thing, have you seen, Wordle?
I've heard of it. Yeah, there's the whole analysis around that, but I've never played it. I know it's shocker.
Have you seen Noodle?
Nope. I guess that's numbers.
Let me show you. Yeah, it's numbers instead of words. Let me bring it up. I'm having trouble. Alright, here we go. Noodle. So you've got to make the equation.
Nice.
Any strategies for the first one? So I've been doing, I think, so what have I been doing? 12, take, like 7 plus 4 equals something. What's that? 9. So that's been my strategy for the first one.
I don't know the rules yet, so what is the aim?
So you're looking, so it's an equation. So you've got the numbers 1 to 9 and then the operators plus, minus, times, division. So with these
You've got to
tools,
guess what the right one is, or the one
Yeah.
that gets the highest number, or
no,
something?
just the correct equation. Like, can be any equation. You just
But
go,
it will tell you whether you got it right or which parts were correct.
yeah, it tells you the right numbers and the position and the right operator. So if I say enter, I've got 1 correct and equals correct, and 4 and 9 are in the wrong position.
Okay. I see. There's a bit of a delay when I say it on stream. I can hear you beforehand, so I'm not waiting. Okay, so 2 of them are correct. And why is that your strategy? Is it thought out or
Yeah,
what?
so I thought it's the most different numbers well, it's what I came up with. I don't know if it is the best, but like I've got plus
Okay.
and minus there, and 1, 2, 4, 7, 9. So 5 different numbers. Thanks, HA, for joining in. And then you just try different things. So yeah, that's Noodle. It's pretty fun.
Is that an app on the phone or is that only on PC?
I think you can. No, I don't think it's an app. It's just on like a website. Might be an app. I don't know.
Oh, I might get into it.
Should we just do this one?
Oh, let's see it through to the end. Sure. So definitely going to keep them the same. And okay, so red. Wait, so what does red and black mean again?
Black is not included. Red is correct number but wrong position.
Holy. Okay, so
Harvard Yale.
4 and 9 for sure are in there, but I guess there's limited, depending on how many operators. Did it tell you how many operations that there are? Is it always 2?
No, it can be. Yeah, no, there's no limit.
Well, it's not plus and it's not take away, so it's going to be times and divide.
Yeah, that's correct. Yes.
Well, it probably won't be prime numbers, I assume, because if it's times and divide, things aren't going to look very nice. So it won't be 1, 9.
Yeah, true.
And if it's 14, the only real things that go into that are 7 and 2, and we already know they don't go there. So it won't be
True.
14 at the beginning if we're
Point.
dividing, because we'd have to divide them by factors of it, right?
True. Maybe
That 15
18?
divided by 3 could be good, and then that would be 5, and then times it by, oh no, because you're going to get very big numbers then.
Oh, we've got no plus. Oh, we could do times. What about 18 divided by 9 times? That's 2 times 5? No, sorry. 2 times 3? 6? Let's try that. Nope.
Well, if we did 169 divided by 13, that is 13, so I don't think that will fit in, will it?
169 divided by, yeah, no.
At least we know now that 18 is not a thing.
Yeah, 8's not included.
Maybe it's not divide to begin with. I think it might be times, because we're running out of numbers that will divide nicely. Unless the first number is 15.
15, okay. Times 120. No, 2 is not allowed.
George is
15.
writing numbers that when divided give the denominator, so we can't have repeats of the things. I assume you can't use 1 more than once,
You
right?
can,
So
yeah, you can have repeats of numbers as well, which is a bit tricky.
it actually helps to limit down possibilities, though.
Yeah. 1 times, no, it can't be divided by. 1 times 34 divided by, what goes into 34? 17? No, that doesn't
17
work.
does, if that's
Yeah.
a thing.
Doesn't work, does it?
But then you've got no space for the equals.
1. The
You can't
equals,
divide
yeah,
that by
it's a
5 either.
single digit answer.
You could do 15 divided by 3, which is 5. And then you can multiply that by whatever number we have left.
15
But that
divided by
won't be
3.
a single digit. That's the problem.
But the division is in the wrong place. So it can't be 15 divided by.
I'm just thinking it's to get it back down to single digits. If we're going to multiply in the wrong place, we're going to make it too big.
All right, yeah. So is it 1 times?
Thinking if we've got 2 digits, it possibly is because the multiplying, but then you've got to think about what you've got left. What digits have we got left? If it is 1 times to get rid of that one, the multiplier factor, what digits do we have left to use? We've got 3 and 4.
3, 9. Oh yeah, 4.
And 6 is a usable thing, right? So 3, 4, and 6. We've got 46,
So I've just
64.
put them all in and not in any particular order.
What
So
about
obviously this
36
is wrong.
divided by 4 is 9?
36 divided by 4
Equals
is
9.
We could have, I thought that was the winner. Damn. Well, we have them all correct. We just need to rearrange them.
Excellent. So what can we do to rearrange these? You could do 36 divided by 9 equals 4, but are we saying they're all in the wrong place now?
No, 1 and equals are in the correct place.
So all of the red are completely in the wrong place.
But we have all of the correct symbols and numbers. 1. So it's 16, I'm guessing. 16 divided by 4.
Well, it can only be 16 divided by 4, which would be
Yeah.
4. And then we'll times that by...
What? It can't be anything
It's going to
else.
be too big. It can't be that
Yeah.
because you've only got 3 left, which is 12. So it can't be that.
Okay, so 16 divided by... By the way, this ignores bed mass or bid mass. So you just do the operations.
So it's just in order. Okay,
Yeah.
left to right. So the black numbers are definitely not used, George, and the burgundy red are used but in the wrong place.
6, so it's 14? No. What? 19? No.
I think it doesn't start with 16. We was on to a winner getting rid of the multiplication early. Unless we... If you multiply any of those numbers individually by each other, they equal a number which is more than a single digit. But apparently the 1 is not multiplying. So we might have to do a very large, maybe a decent sized number divided by a big number.
40. So
254 divided by... That could be single. Yeah, that equals 6. Oh, we've already used the 6.
So what's 13 times 4? 52. It's
That's 64, isn't it? 4 times 16 is 64. That doesn't divide by 9.
Yeah.
16 times 3 is 48. We could divide that by 4, but we'd have to... No, that's more than we need.
16
It
times
definitely need a bigger division.
Divided by 6. Where's the 9? Oh, we still need the 9.
I don't like that multiply. It's frustrating.
1.
And George, one of the rules is we can't use the same number twice. So
Well, now we know, but you could originally, but we can't anymore. I don't think. Yeah, no. There's no space. 1 times 19 squared. Oh, there's no exponent.
yeah, but we
operator.
can't use that. We can't. That multiplier is a real pain.
So
If you're going to multiply something by 16, you've got to have a really good reason because that's going to be very large. Ideally, we put instead of 6 the smallest number there, surely.
13 times 4 is what? 52? 52
That's 13 times 4 is, yeah. 52
doesn't divide.
doesn't divide by anything nice.
What is going on? Why can't I figure this out? Oh wait, no, you don't. Yeah, we would have to do
I'm
the
not sure on one of the numbers here. This is the thing, right? Because if I can use the same number twice, but I don't think we can because we have to use the symbols that are red right now. Is that correct?
Yes, we have to use.
So literally, we have to use those numbers in a particular order.
Oh, it's something like it's a no, but then we need a multiplier still.
The multiplier is a pain because if it doesn't go second, I'm really annoyed by it. Can I see?
It's impossible. Something, we already tried this, didn't we? Something divided by. Oh, could it be like a fraction multiplied? Maybe it could be. 13 divided by.
Oh, it could cancel.
6.
Yeah, we could have something over 9 that would cancel. Yes.
Is this
13
it?
divided by something. Okay.
2.5 times 4. No, that's 10.
1, 3, 6, 9. I need a bit of pen. I'm going to write this down now because I think better when I write down.
14 divided by 6. What's that?
14 divided by
2.5.
6. Just put 14 over 6.
That's still 2.5.
That's like 7 over 3. That's something because we've got a 3 to multiply it by, and that will bring us back up to 7. We can't use a 7 though. Yeah, it's not that. So we have to use 136 divide or equals 9.
This was a mistake.
What, to try and do it?
Yeah. I'm having fun.
Oh, I like these sort of things because I just can't give up on a challenge.
Oh, 19 divided by 6 is a third times 3. 3 and a third times 3.
19 over 6, yeah, is still 19 over 6. That's not going to get anywhere. This is maths, really. I don't know if anyone knows what a real maths job looks like, but they literally sit around with a cup of tea all day thinking. They try different things. There was a meme online, and they had two different people. One person who was watching Netflix, and they were sitting still, just focused on it, chilling. And then the person who was doing who was a maths professor doing problems all day, was spinning on the chair, thinking, jumping up and down, is distracting with all these sort of thoughts. And it really doesn't happen instantly. You have to sit it out, wait it out, and try everything and not give up. 1, 3, 6, 4, 9, divide and equals. Okay, so that's definitely a 1. That's definitely an equals. So it's a single digit finish. I could go down all the different permeations.
It's tricky if they stick a fraction in there. Makes it harder. 2.5 times, no. So 4.5 times, no, we don't have a 2. One times 1 times 1, not possible. We need to use 1 multiply 3 6 division 4 equals 9. We need to use all of those. There's no 0 allowed. We just need to rearrange the numbers in the third row into a correct equation. I'm just going to, so we tried it there. I'm just going to stick numbers in. No, wait, it can't be there, can it? So it's not there,
4
it's not
divided by
there.
6 is 7 over 3. 7 over 3 times 9 is going to be 21. So that's not going to work.
I'm going to cheat a little bit. Oh, it doesn't.
Why is that?
They don't let you do it. They don't let you input the equation unless it's correct.
Good. No one likes cheating. Why are these numbers? It's like somebody chose these numbers, and we just have to figure it out.
I don't know. This one's too hard. Times. The division is not there either, though. Wait. How can... Oh, okay. It's got to be there and then there. Actually, it must be this arrangement. It must be division first, then multiply, I think. Yeah. No, it can't be. It's got to be multiply, then divide. No, but it can't be. Wait, I'm really confused now. Divide? It's not there, it's not there. Oh, it's divide there. Then multiply. It's not Wordle. So it's got to be something divided by 1 divided by 4. Oh, it's like a fraction multiplied by something.
It's not a 0. Why is that? Oh, there you go.
That was just a placeholder.
Oh, so you've gone really small to begin with. Not explored that yet. So that's a quarter times 6, which is 1.5. Oh, times 62.
No, it's just numbers. I don't know what's meant to go here.
Hey, I think you're closer, yeah? 1 divided by 4 is a quarter.
Yeah.
Times 6 is 1.5.
Okay. But this needs to be a 2-digit number.
Oh, but you haven't got enough. Oh gosh.
3. Quarter of... Oh my gosh. A quarter of 36 is 9. Is that right?
Yeah, it is, isn't it?
Oh, 2 off. Oh, a ninth of 36. We got there. We got there. Wow.
Yay, we got there before the final line, thank God.
That was a tricky one. You won.
Woo!
That's mean, putting a fraction multiplied by a 2-digit number. The other ones I was doing were much easier than that.
Well, you never know what you're going to get, huh?
We didn't lose.
George thinks we lost. I think we won.
9 to 36 equals 4. There you go. By the way, probably, maybe you're thinking it's not obeying the laws of BIDMAS, but yeah, as I said, it's not really. I mean, just meant to do the operations in order for this. Alrighty, that was a bit of a marathon. Oh gosh.
If the floor is lava, we avoided the floor.
We went for 2 hours, really.
Well, it takes what it takes. Right, stick to time next week.
Yeah,
Shall
well,
we?
yeah, well, that was good though. All right. See you next time then. Thanks for tuning in, everyone.
Good to see everyone.
We are out.